Okay, before I begin, have you heard of the company National Instruments or NI?
Multisim?
Multisim, yeah. Sakto, ang current developer sa Multisim, no? Electronic Workbench na before, then ilang i-acquire, then manang Multisim. Mm. So aside sa Multisim, so what have you heard of NI pa ba? I'm not sure if na ba sila yes, sakto si Jason, instrumentation. Mm. I'm not sure if na sila actual nga manufacturing plant ba here sa Philippines, but I'm sure na sila satellite office, especially for sales, no? Especially for sales of their products. Ilang products mainly are into ito, instrumentation and control, uh, basically data acquisition. No? Isa gina sa ilahang forte. And so, okay. Software, yan, ako sa software. Ang hardware mo, kato, no? Ang hardware nila is into data acquisition, electronic instrumentation, testing. Whenever na yung manufacturing plant na need to measure data, acquire data, no? Connect lang na to sa topic nilang Jeffrey last meeting. No? Through sensors, man na to ma-gather ang data, no? Ma-measure, I mean. So what will we do with the data? So the interface here, ang interface between the sensor and the the processor, so to speak, kay isa na sa mga products sa NI or National Instruments. Tapos sila product, into kan nga po, no? Again, into data acquisition and electronic instrumentation na software-based, which we call LabVIEW. No? Ano yung pag-spell LabVIEW. So, ang pag-dog sa uban. So, yan na, pag-spell na LabVIEW. Muna ang ilang isa sa main na pod ilang main pod na kuan products. Tsada ka na siya nga product in industrial and na may academic version ana. Okay? Actually na community version nga pwede na nato makuan. Ga-allow ra si NI nga i-install for personal use ra gyud, no, not for academic gani nga use, for personal nga kubi-kubi nga use, no. So nga nga version sa LabVIEW. So you could go to their website, sa ilang main page lang daan ni.com. Makita na nato ilahang sa ilahang kuan gid, ilahang what their company is all about. Napon sila kuan into radio frequency. Yeah, I remember sa tong research center na ganito miha. Sa IIT. Yeah. IIT, ang ilahang radio frequency laboratory was where they are designing antennas. Isa sila ang mga test equipment kay NI, National Instruments. And then napos sila yung mga products that is into education. Tapos sila yung mga sa tawag ganyan kanang module, proper trainer, yeah, electronic trainers. And well, in fact, katong mga laboratory manuals na itong gigamit sa Indus ug sa Logic, NI ang nag-develop ato. No? So if you notice, ma-mention nun sila sometimes dito nga ang next na step is to go to the board and perform the experiment, pero sa to sila na ma-perform gamit physical nga kuan. So mo to, no? Kung asa ang tato i-perform, i-simulate man to, di ba, sa multisim. Pero kung i-perform to in actual, dito to i-perform sa NI nga actual na trainer. So this is a great company na sudlan, no? So most ECEs nga graduate sa Philippines nga kuan kung makasulod sa NI kay if dili lang pud ma-assign noon kay I think into sales man to sad noon kay ang mga ECE raman I think ang na proper nga background or foundation to not only to explain but also to handle no the equipment kailangan gina manufacture sa NI. So ang ilahang mga products kay mainly into systems no systematic nga point of view dili chips dili semiconductor so systems or electronic systems. So I've attended one of their webinars. Okay, pandemic naman to I think. So webinar. And what I've learned from them, I'm going to share to you this afternoon. Kay timing kaayo. Ang supposed ang akong topic device is interfacing. But then again, kung interfacing alone, medyo di ka na to appreciate if the first place no wala na to na hear tong report nila sa previous reporters and dili to siya put into a much larger perspective which is data acquisition. So that would be our topic this afternoon. Klaro ba akong screen? I-share data acquisition 101. Spec and select your next system. Okay, thank you. So this may seem this may seem like I'm selling products here. Pero it may seem that way kay ang original nga nag-share ani webinar kada si Derek Burrows. Kay mo gito mo gina ilahang main nganong pregnant man siya. mo gina ilahang main nga tumong no mag-conduct sila ay samok English. Sige, kuha na siya. Have. So, yan na ginailang main nga tumong no, whenever they conduct seminars. At ang endpoint ka na, they're trying to sell their products. No? Yan na dili na siya kanang taboo or it's not something hidden. Especially puhon no, ma-engineer na mo and kinanglan na mo mag-apil og mga seminar sa ICEP and matingala mo nga ang speaker is magpamaligya may product. And yan na gina, no? Maligya na product yun. Pero while they are explaining their product, i-explain mo po nila ang background sa ilang product. So, nagyapoy theory. So, the same gyapon din, no? So, most of the terms, perhaps nga ilang nga ato ma-encounter this afternoon kay vendor specific, no? What that means is, sa NI lagi siya ma-encounter, no? So, vendor specific siya, NI lang ang baligyaan na. Pero sige lang, kay kung ano po ang NI ka ng known naman gid na sila. And dili ko recount og ilang mga direct competitors. Unlike lugar analog devices no nga daghan man kaayog manufacturer og semiconductor circuits o chips. Pero NI isa lang ako madumduman. US company gyapon, Teradyne, no? Test equipment gyapon sila. But I think NI is much bigger than them. So I'm sure whichever industry you'd be in the future, in one form or another, maka-encounter gid mo og national instrument na equipment. Okay? So mo ilahang primary na mga ginasell equipment into data acquisition. So this is supposed to be the outline, no? Basics, beyond the basics, software and building your system. So these are supposed to be the goals. So understand specification tables, ask tough questions to build a great system, and narrow down our choice of NI hardware and software. So I think kanip lang daan, this proves my point earlier. Manarrow down atong point kung unsa atong pilion nga NI hardware or software. No? So these are the data acquisition devices and systems. Data acquisition shorthanded as DAC or DAQ. Okay, DAC systems. NI has PXI, compact DAC, USB-based na mga DAC devices, and PCIe DACs. So, ang PXI is, I think, ilahan ng own brand of their PCI na devices. So, what does PCI mean? PCI. Peripheral Component Interconnect. No? So, especially katong build o ilang own nga mga PCs o computers kanang part bito sa motherboard nga kung asa ninyo i-kuan asa ta mag plug and play lang bitaw mag-connect og mga kuan mga other na components manang PCI local bus or peripheral component interconnect, no? PCI local computer bus for attaching hardware devices na computer. So ilaha is PXI. Okay? PCI gyapon, what ang i-connect da is of course ilang hardware, no? So na yung mga USB based gyapon ng mga DACs or data acquisition equipment, no? So DAC devices, they have USB based PCI or PCI based, okay? DAC devices include multifunction I/O devices, digital I/O devices, analog output devices, and sound vibration devices. Kibali, muna siya ang first na interface, no, between the sensor and the system. So, dili na to kibali i-connect atong mga sensor, okay? Whatever sensors they are. And NI hardware are capable of interfacing numerous kinds of sensors, no? Katong mga sensor bitaw nga gipang discuss lang nilog lang Carl Joffrey last meeting. So readily ma-connect to sila sa mga NI nga systems. There are general purpose na DAC devices, no? Voltage, ako ang mas-discuss later na voltage based, no? Meaning mas unsa ang pwede ma-connect sa iya. And apo yung mga DAC devices na sensor specific, no? Meaning if thermocouple siya nga thermocouple atong sensor na ay special nga DAC device for the thermocouple and only for the thermocouple. So we also have DAC systems, modular data acquisition systems that consist of chassis and I/O modules. Ang nakatsada sa ilahang style, sa ilahang DAC systems kay modular siya, meaning whatever ang atong need, no? Connect lang nato dito, just like this one, no? Wala siya cartridge, no? Or sa ba? Yeah, cartridge akong ma-relate yun yan eh. Kaya itong kalaan nga tape sa mga kalaan nga video games, no? Kung muna na siya itong kinanglan, i-connect lang nato sa atong chassis. Yan na lang. So plug and play, diretso la dali ra kay siya masaksak o dali ra kay matangtang. No? Yan na. So mo naka-advantage sa ilahang system, no? Dali ra kayo matun-an. Yan na. So yeah, so the basics of DAC. First, we go to sensors and signals. Later, sa data acquisition devices. And lastly, sa computer software na mag-handle sa data nga na-gather sa sensors through the DAC devices. So technically, ang interfacing gid class is nalagid kanila gid ang nga part, signal conditioning and analog to digital converter. Ayan na. So mo gid ang interfacing, how can the computer properly read the data from the sensors. So kinanglan taog kani data acquisition device mo ni siya ang interface, so to speak, no? So pero na naman lang taani nga slide ato na lawson tanan. So as ECEs, we've learned there are two types of signal. We have digital signal and analog signal. Okay? So from the real world, from the analog world, we could measure different kinds of analog signal. Kung digital signal nga gikan sa analog world, I think that would only be from switches, no? Mechanical switches on and off. Kay if kani nga actual data or actual nga digital signal, for sure gikan ni siya sa analog, no? Gi-convert na ni siya pamaagi sa digital to analog, analog to digital converter. Kani ba atong gakakita sa atong screens karon, no? For sure this kind of data gi-convert na ni siya from an analog one. Pero na may mga natural na digital signals, pure on and off, no? Pamaagi lang noon sa switch. No? So digital and analog. So sensor overview, I think muna siya ang gist sa na-discuss sa previous reporters. These are, on the first column, are different kinds of parameters or phenomena na i-measure. And on the middle column are the transducers and the sensors. So, muna ilang ipang-discuss last meeting. Thermocouples, photosensors, microphones, strain gauges, LVDTs, accelerometers, and PDH electrodes. Ang sa last nga column, this is also an important one, is unsa nga klase nga parameter ang output sa mga sensor, no? So for example, light sensors, no, vacuum tubes or photosensors. Ang ilahang output, electrical characteristics ng output is current, no? For temperature, we've known RTDs or resistive temperature devices. So itong other nga, thermistors, no, the thermistor. We know nga ang output sa thermistor is if there is change in temperature, so change in resistance, no? So, resistance. And dapat kabulot kung linear or non-linear, of course. Kung thermocouple, voltage, no? So, ang point here is, not only should we know what our sensors are, no? I think mas dali mo na siya. Okay, familiar man ta sa mga sensors. But we should also know what type is its, or what is the characteristic of its output. Technically, gamay naman ang atong choices sa ani. It either could be voltage, current, or resistance naman gyud. So dapat makabalata kung ang output ba sa atong sensor is voltage or current or resistance. So that we'll know what kind of circuit atong i-interface between it and the interface. So napay interfacing circuit between the sensor and the interface, which is the DAC device. Well, again, depende sa electrical characteristic. Na may uban nga diretso na nga i-plug. So that's the first step, understanding our channel, no? Understand your channel counts. Your test requirements or measurements needs may include a mix of, that's what I've said earlier, voltage or current or on and off ng signal. You should know the sensors and the actuators. And you should also know the specialty IOs or specialty input-output. No? Like, sa nga pang protocol, no, nga needed, serial ba or CAN or USB or mag-need ba siya LAN, no? So these are the considerations, no? Factors na ito i-consider. So example, vehicular data logging. These are the sensors, no? Example, no? Try to imagine this one. Ano nga, ito, ni? Automobile manufacturer. No? So within the manufacturing plant, of course, towards the end point sa manufacturing plant sa automobile, Toyota, Honda, no, whatever. Nagid na yung part sa process na i-test ang onboard vehicular electronics. Kaya kabalo naman ta nga even ang mga not so smart cars right now, naging slay onboard nga computer or electronics. So how can NI help? No? So NI would provide test equipment, and the manufacturer should know what kind of sensors nga iyang kinanglan, no, or need. So let's say for example this one, no. So na siya thermocouples, accelerometers, strain gauges, torque sensors, no. For sure kaning torque sensor is to measure the torque or the speed or speed of rotation sa engine, sa wheels. Yan na. So, yeah. Sa digital I/O, kabalo dapat siya nga need niya og 4-channel na encoder, no? Measure the RPM. And na siya specialty I/O nga needed, which is the CAN bus. So kani nga mga, this is just an example. The point here is as the lead test engineer or supervisor perhaps, dapat kabalo ta unsang mga needs, no, sa atong test equipment, from the sensors to the communication protocols needed. So now we move to signal conditioning, no? So what do we mean when we say signal conditioning? Condition ang signal. Somehow i-prep, no? I-prep ang signal para ma-read or ma-handle sa DAC device. So signal conditioning improves a signal that is difficult for your DAC device to measure. So lagi i-prep niya. So let's say for example, from a noisy, low-level signal, it should undergo signal conditioning para makakuha tag manageable na signal. No? Filter na ang noise, amplify na. No? So we have these common signal conditioning techniques which we have learned, no, previously from electronics to palangdaan, kabalundaan ng mga terms. So that's why I believe ang mga ECE gid ang suited for the job, no, for instrumentation and control and for testing. No? So mga ECE gid ang best people to work with and work for National Instruments. So if ang output sa atong sensor is voltage, so pwede na to i-amplify or i-attenuate. Okay? So na po reason nganong need for attenuation. No? I think we'll learn that later. So also filtering to remove unwanted noise, and isolation. No? We've known what isolation means para i-separate ang one part of a system to another. No? Maybe mas delicate ang next na system, so kinanglan na to electrically isolate ang one part to another. So these are some examples of signal conditioning processes na i-undergo sa different transducers, which is on the first column. So let's say for example, thermocouple. So for thermocouples, the output voltage of thermocouples need to be amplified, to be linearized, and to undergo cold junction compensation, no? Whatever that may be. So anyway, Yeah, technically, there are NI products nga dili na kinanglan gyud ta mag-design og mga particular circuits for this one. And we'll know later why. So the point is, different sensors call for different signal conditioning processes. No? So dili parehas tanan. Dili parehas tanan because dili man parehas pud ang mechanisms for each output mechanism for each sensor, di ba? May sensor nga yung output voltage. May sensor nga yung output is low voltage, no? Kinanglan pa-amplify. Na sensor nga output is current, no? So, for example. So, we have two DAC device products of NI here. NI 9201 and NI 9210, 9210. So, for example, a voltage input device or a sensor that outputs voltage can understand many sensors. Ang voltage input device, the I is kaning DAC din nato. A voltage input device can understand many sensors but needs external circuitry. So additional circuitry can add complexity and failure points to your system. So say we could save time by building our own signal conditioning with sensor-specific DAC devices. So kaning duha ka different input devices or DAC device from NI, ang difference lang is the one on the left is a generic or general purpose voltage input device. So ang expected na input sa kaning NI 9201 is voltage, no? So dili siya necessarily makabalo kung unsa nga sensor ang input sa iyaha, basta kabalo siya nga ang output ato nga sensor is voltage. Pero dili directly i-connect ang sensor sa iyaha. So kinahanglan pa og external circuitry. So external CJC circuitry, I think mo nitong kuan ba? Cold junction compensation circuitry. So external amplification circuitry. So for those who have handled thermocouples before, gamay kayo ang output voltage sa thermocouple. Dili na gani ma-measure sa atong conventional nga multimeter, no? So kinahanglan pa og kuan. So how much more for the NI9201? So para i-connect ang thermocouple sa NI9201, kinahanglan pag-internal circuitry. Pero naapoy product ang National Instruments na sensor specific, like this one, the NI9210. So the NI9210 knows or requires ng iyaha, nga ang sensor nga i-connect sa iyaha is the thermocouple. So the thermocouple will be directly connected to the thermocouple input device, which is the NI9210. Ang disadvantage ng of course, is dili po siya pwede magamit sa other nga kuan, no? Dili po siya pwede magamit sa other nga sensors. Thermocouple lang yun. Okay lang kung thermocouple or temperature lang ang Fermi gina-measure sa atong manufacturing plant or sa kanang industry. Pero if lahi-lahi nga mga nga mga measurements, lahi-lahi nga mga parameters. So nagya po'y reason, no, nga mas advantageous perhaps ang N210 kani. Okay? So dili siya it's not dili siya one versus the other, but depende gid siya sa need, no? Depende siya sa need sa industry. So if you need sensor-specific I/O, you should use a DAC system instead of a DAC device. No? Kung sensor-specific, you'll get better performance from conditioned I/O modules for common sensors. So ang NI na nag-ingundaan karon na if we are expecting to measure different kinds of parameters, or if we are going to handle different kinds of sensors, much better that we acquire DAC systems and not just DAC devices. So specialty IOs. Your DAC system may want to include some specialty IO like RF measurement, and access industrial communication like CAN and LIN networks, no? Can be helpful. It can be helpful for this IO to be part of the single measurement system. No? So kaning first na column, the DAC device, this has no specialty IO because I think this is a USB based na device, no? Kani. While ang the one in the middle, a compact DAC system. Compact gapon siya, no? Meaning, well, name plan niya, daan niya alone, compact. Pwede siya mas convenient siya, dadon. So it has access to automotive networks like CANs. Wala kayo ko yung background ng CAN. Basta akong nabalaan lang is, industry based ni siya na protocol. So di kaya natin madunggan. No? Pero if we need to have access to most common communication networks, so we use a PXI system. So access to huge set of specialty IOs like RF, oscilloscopes, relays, and many more. So again, dili ni siya, one is not necessarily advantageous to the other, but it's just that kung sa atong need, mo pala atong i-acquire. So step 2 is understanding the DAC specification. No? Muna na siya ang thing that defines, no, or specifies, characterize our DAC system. So exit sa ko gamay. Check lahi nga screen na I mean nakoy gusto ipatanaw sad. So itong earlier, NI9210, no? NI9210. 9201. So, here it's in. There are the C series voltage input module, diba? So, man itong NI 9201. Ano siya? Modular, no? Igala na i-connect sa isa ka system. So, sa specification. Notice no nga, medyo naging siya kamahalan sad. Ang pinaka low end na NI9201 is 655.00. No? So dili siya pang academic na purpose unless ang kanang academic institution is dako gid kayo og budget. So for industrial lagi siya. Price pa lang daan alone. Maglisod siya nga for kubi-kubi lang or for study. The real thing naman gid ni siya. Ito isa daw. Diba? Diba? Same nga po ni Lail ang website. Magkons ko ni middleman. Diba? Featuring a compelling combination of speed and channel count, the NI9201 is a 500 kilosamples per second plus minus 10 volts, no? And 8-channel 12-bit C-series voltage input. So kanina pa lang daan, dire pa lang sa iyang primary nga mga characteristics, kabalo na taon sa iyang capability. No? So, mo nitong nasa atong last slide nga gibiyaan na resolution, range, and weight. Resolution, range, and weight. So, although naman po din sa specification sheet, of course, So we do not need to really go deeper into its specs para mabalaan mo sa iyang capability. So again, 500 kilo samples per second, plus minus 10 volts, 8-channel 12-bit. So kanebe, NI 9201 series. 9201, 9202, taman. So silang lahi-lahi. Nag-differ sila sa maximum number of single-ended analog input. 8-channel lang ang pinakaubos na ay 9205 na 32 channel. Yang analog voltage input nga range, ang mga nasa lower end from negative 10 to positive 10, naapoy negative 60 to positive 60, no? So again, depende sa need, no? Depende sa requirement. Yeah. So, balik ko sa itong previous nga slide. So for each signal we acquire, we should have an expected precision, amplitude, and signal frequency. And make sure your DAC device meets those needs using these three key specification. Okay? Resolution, range, and rate. So ang resolution na mag-handle sa precision, ang range handles the amplitude, and ang rate, of course, ang frequency. So we'll go each one of these, no? One by one. So for example, resolution, no? Ang point lang here is the larger the resolution, the better, no? Mamagin ang rule of thumb. The higher the resolution, the better. But ang question if kung need ba, no? Mamagyan po na unsang klaseng mga signal ang kinanglan. So if ang atong gina-measure na signal is radio frequency signal, of course that calls for a higher resolution na DAC device. Kung dili man lang gani need, no, di man lang gani need ang so ito siya precision, no? Precision, no? So pwede naman lower bit ng resolution ang kinanglan. So so example, a 1-bit increase doubles the resolution of your device, of course. So expect prices to climb quickly with increased device resolution. So for this DAC device, NI-USB 6000 and NI-USB 6002, ang difference lang nila is a 4-bit na resolution, but notice that the difference in price, no? Ang kani-kaning isa is 175,000, no? For a 12-bit resolution nga DAC device. Both of these are USB based. Okay. So again, dili man all the time na need yun na to dagko nga resolution nga DAC device. Depende lang sa kinahanglan. Okay. Kaya if magpalit tag ingani, or if mag-recommend mo ingani sa inyohang industry, and then di man lang kinahanglan og high precision na data, so pwede naman ta mag-settle for a lower, no? But cheaper na price. Also the range, you know, we should also consider the range. I think duha man dapat ni nga duha ni siya. Naka-animate man dapat ani. Duha ni siya ka sine wave. Ang isa is mas ako, isa mas gamay. Pero ang endpoint lang ani is if ato expectation sa atong signal is a larger na amplitude, so dapat mas makuha pud ta og DAC device nga mas lampas ato, no, or mas larger nga range, no. So if we expect nga ang maximum nga input, maximum input nga output sa atong sensor is 8 volts, so much better makuha ta og DAC device nga na range pod nga makuha niya ang 8 volts, like plus minus 10, no? Katong plus minus 10 pwede na to. Pero if expected na nga ang atong signal is na sa mga plus minus 2. So sayang if ang atong kwaon is plus minus 10 nga voltage range. So basig pwede na ta makakuha og plus minus 4 nga DAC device and mas cheaper, no? So kana need lang nga makabaluta kung sa mga minimum maximum mga voltage levels sa atong signal. So if you're measuring less than 1 volt of a 10 volt range, you're losing out on 90% of your resolution. So selectable input ranges improve your accuracy over more tests. So for example, this one, PCIe 6043, it has selectable input ranges. Pwede plus minus 0, 0.2, pwede plus minus 1, plus minus 5, plus minus 10. And last R is the rate or the sample rate. Again, rule of thumb, the larger the sample rate, the better. Minimum requirement is twice, no? Twice the frequency of the input signal. So to accurately represent the frequency of your original signal, you must sample at greater than 2 times the maximum frequency. To accurately represent the shape of your original signal, you must sample between 5 to 10 times greater than the maximum frequency component of your signal, no? So in theory, wala ba niya itong ginakuan? And I believe this is correct, no? Okay, all systems in communications adhere to these rules first, no? To accurately represent the frequency of our original signal, okay? Mo naman yung atong characteristic na ginabasehan ang frequency sa atong signal. So twice the frequency is enough. Pero if you want to accurately represent the shape of our original signal, it's much better nga ang sample rate is 5 to 10 times greater than the frequency of the original signal, no? So we recommend sampling at a minimum of 10 times the frequency of your signal. So you should also consider simultaneous sampling. The sample rate you see on a DAC device may not apply to every channel. So there's multiplexing and simultaneous sampling. And I think ang mga NI devices are no? Simultaneous sampling. So example, comparing products online. Ito daw, mga different kinds of PXIe devices. So na mga price. Yan yung magyapot ito nakita earlier, di ba? Sa 9201. No? So channel count, the rate, resolution, the range, signal conditioning options, kung available ba ang filtering, available ba ang low-pass filtering, analog input isolation, and so on and so forth. So kung industry di naman na ginatanaw ang price, no? Kay Needman. Sabi ba, $4,000 for this system? Pila ba niya siya? 4 times 50. 200,000 pesos. For A-test equipment, kaya naman gyapon sa mga industries gid. So recap. So what bus is right for my measurement system? So to answer this question, let's try to observe the table. So different buses are available na USB, na Ethernet, na PCI, na PCI Express or PCIe, na PXI, and PXI Express. So does that mean nga ang Ethernet man sila ang best choice gid ani sa tanan because do ka book yung best na kuan na column, no? Does that mean nga ana? Depende, no? Perhaps because kung Ethernet lang kuan nga bus, na lang siya maximum nga 125 megabits per second rate, no? What if ang atong application is mas larger than this one. So dili makaya sa Ethernet nga bus. So we need PCI or PXI. So again, as I've said earlier, depende sa application. At least we're given numerous choices by NI. So what kind of connectivity? No? Ay screw terminal, no? Kaning screw, as the name implies, diretso lang nga i-plug dire ang sensor, iyahang terminal, then i-screw in lang. No? Pwede ka pong BNC. BNC BNC connector, kanang coaxial nga cable, for sure iyahang medium ani coaxial gini siya. Kanang bitong let's say for example, ang atong gina-measure is signal, no? From sine wave or whatever, kanang ma-view ito sa oscilloscope. So dili siya pwede i-screw ang kuan, ang oscilloscope mo probes. So, kinahanglan BNC terminal nga DAC device. Apoy VHD CI, no? Connectivity, need na siya. So again, depende sa atong application. So how often do my tests need change? So modularity is the easiest way to quickly adjust to changing test requirement. So if changes are rare, purchase a DAC device or a modular DAC system that meets specific needs. Standalone ng mga DAC device, katong mga USB-based bitaw. If there is a need for occasional change, purchase a modular DAC system. Adding new modules for new iOS needs allies only. But if frequent nga change, purchase a modular DAC system and consider starting a hardware library with additional modules. So I think kanina to nga system ang mas mag-require og software, no? Kaning frequent changes. Kaya pala natin isa ka standalone bitaw nga system nga very versatile. Kaya kailangan naman siya og lahi nga kuan, no? Kailangan naman siya og mag-handle of different kinds of tests every now and then. So you should also consider where will I take my measurement, no? The environment, okay? Kung sa nga environment na siya nga, kung sa klase environment ana nga kuan, nga kung asa na to ibutang tibali ang atong test equipment or atong mga DAC devices, no? Kung sa laboratory-based lang, no need for a more rugged nga device kay kabulmantang ang laboratory is medyo mas pristine man nga condition. Whereas for outdoor or field environment or hangars and large laboratories nga where dust is prevalent, so kailangan tag mas dust-proof, no, or more rugged na mga systems. Or kung init pud siya, no, kung init nga mga environment, outdoor, outside, yan na. So these are the different NI DAC devices from least rugged to most rugged. Okay, so when you say rugged, mas suited siya sa different kinds of harsh environments. So mga USB-based is medyo, I believe, least rugged na sila. No? Wala na siya mga compact na mga devices. Di kayo suited for dusty environments or very hot environments. So do I need my DAC investment to last? So kani medyo sales pitch na ni siya for the NI salesperson. No? So consider, sir, purchasing a premium na DAX, NI system because of the disadvantages, no? Advanced replacement and system RMA. Na dili makuha for a standard lang na purchase. So kani medyo na siya. Sales related ni siya nga slide. Kaya mo go deeper ano. Last part is selecting the DAC software. So I think for National Instruments na slide tulo kuan mag-gloss over lang ko ano yung mga slides focus ako dali no. Ilahang mga systems are capable of handling three types of software no. Kaning Flex Logger, this is a or an application software from them also, and I'm magyapaning Flex Logger if the technical person or if the person handling has no technical background in programming. Okay, Flex Logger. Marshag kuan, marshag the usual nga application software sa computer. Okay, i-install lang and then i-operate like Microsoft Word, browser, ano lang bitaw, Excel. So no programming needed kaning Flex Logger. So pero what if the test person is more versatile? So mas daghan siya nawala nga programming language and ganahan siya mag-program. No, so iyang testing processes is gusto niya ipaagi og programming. So ang mga NI systems are also capable of reading no these programming languages. C, C++, C Sharp, Python, MATLAB, no? Pwede gani, Visual Studio, pwede pod. And then naapoy somehow middle ground, no? Ang LabVIEW. LabVIEW is not technically a programming language, pero some still consider it as a programming ano lang, dili siya programming language, pero malag na siya programming involved, no? Na may mga kuan, input output, may mga if else then, yan na bitaw. Pero not necessarily code based, no? Dili siya code. May siya block diagram based na programming. So lingon ni siya ning LabVIEW, no? So depende sa need or specialty sa test person. Kung wala siya programming background, pwede siya gamit og Flex Logger. Kung medyo programming intensive siya, pwede siya mag-stick sa iyang own na balaan. Pero makagamit yapon siya sa NI ng mga equipment, no. So ang point lang ani nga slide is ang NI ng mga equipment are versatile, no. Dili magmatter if the test person has background in programming or not. Kani, no? Okay. Okay naman siguro ni. So, yeah, ang NI equipments could convert LabVIEW block diagrams to C nga code. So that pwede ra gyapon ka as the person maka-program without knowledge of programming languages. Pamagi sa LabVIEW. So na flowchart to. Are you willing to program? So kung no, better use Flex Logger. If yes, are you experienced programmer of C, C++, C Sharp, MATLAB, Python? If no, better use LabVIEW. But if yes, you could still use NI DAC devices. So ang last nga page is as the sa tawag attendee of the webinar, you could choose your training path, no? Pwede free, pwede paid. So all of this pwede ma-cater sa NI. Nasa yung mga free nga mga trainings and tapos like paid trainings that could lead to certification, of course. Ay, napatay hindi eh. Okay na ito eh. We'll end here. Any questions? Ang takeaway lang ani class is if ever you become test engineers in the future or whatever industry man mo mabilong, hinumduma lang na siya nga pangalan, no? Kaya basig pwede niyo na ma-recommend sa inyo ang mga bosses and mga supervisors in the future. National Instruments. Wala mo naman kung gibayaran ni NI para mag-conduct ani nga talk. Pero, well, established na mo ng NI. No? For any kind of industrial need, at least for in the area of instrumentation and data acquisition, I think sila gid ang leader sa iyan ng industry. Oh, yeah, sakto mao. High, very rugged yun dapat ang mga DAC systems ginasa sa outer space. So, aside lugar sa, ako lang naunin nga point of view, pero di mo ka-expect kung saan na dito. May bitaw. Kapatay mo itong movie naman noon to, no? Pero itong The Martian bitaw, ito sa The Martian, no? Bantay ka sila mga test equipment. I think accurate mo ito ilang mga test equipment na i-portray sa salida. Oo. Gabi ka kuan. Yan na. That's what we mean when we say rugged. Dapat capable siya of withstanding different harsh conditions. Captain Marvel,